This is our augmented reality and poker senior design project. So,
our objectives is to make a Android app that will scan cards and display on the screen the poker hand and things it sees. We're doing this for Lexmark. They having us do this. The eventual goal that they have is to make augmented reality glasses to help train their new hires on repairing printers and stuff, have artificial intelligence and augmented reality glasses help them along the way in repairing.
So at the beginning, the customer Lexmark proposed us to use some framework like ML kits and Aircore, but the first part of the class was purely architecture. We were doing the architecture of the app, and when we went on the second part of the class, doing the actual implementation work, we figured out that having ML kits, which is basically a TensorFlow made for mobile devices, and like using ML kits and Aircore at the same time, making them communicate was pretty hard. So we settled on doing something else. So using Wikitool instead. Wikitool is similar to Aircore. We could have used Aircore too, but since we wanted to have a really broad coverage of Android devices, we settled on Wikitool because I think that Aircore only cover Android 8 and 9. And basically, what's happened is that the first plan was to build a custom recognition model, probably using our networks on ML kits, so TensorFlow, and integrate it with Aircore to overlay the ends that would be recognized. But since we couldn't really have ML kits and Aircore communicate with each other, we settled on just using the augmented reality framework, like either Aircore or Wikitool, because either of them come with a tracking feature that allow the user to upload images, and both API will build custom models to recognize each of the images. So we don't need to use ML kits anymore. And the choice of Wikitool over Aircore is because there is a broader Android devices coverage. So if we use Aircore, we would only have been able to cover Oreo and Nougat, and using Wikitool, we go from Oreo to Lollipop. So 88% of the devices in the market.
So we had a planned UI and a actually implemented UI. So here's the UI, and they were mostly the same, but here was our original drawings of what we would have. Was an app, and when you click on it, there was a menu. One button would be to be able to start the app. Then it would show in augmented reality what was on the app. So everything in the world with nothing extra. But then if it saw a poker hand, it would display on the screen, you have a full house. So there's a full house right there. And then when you click the exit button, you would exit. So that was our planned UI. So here's our actual UI that we implemented. It's basically the same. When you click the app, you get to this menu. There's a start, the augmented reality view. If you're in augmented reality and there's nothing, it just prints what's on the screen. That's a table. And then if you put stuff on the table, it highlights in augmented reality what cards you have, and currently it's printing which poker hand it is on the terminal. We're working on printing it on the on the AR view. Yeah, so Here it is on the terminal. It says full house 8s over 5s. You can see it's full house 8s over 5s. So we had a little bit of a problem with these cards because I thought all these cards were the same, but these are a white background instead of gray, but I got it working sort of. But first I'm just going to show a quick video of what it does in case this doesn't work.
Always a good idea to have a backup.
So here's the app. You go into augmented reality, just look around, there's nothing. Then if you go over poker cards, back up, then you can see here it says 2 pair 10s and 5s on the screen.
Was that more or less in real time?
Yes, I just filmed myself doing this.
Okay.
This is exactly in real time. And then also, so the back button will go back to the menu, the main menu. If you hit that, then it'll go out. You can open it from starting it. There you are.
Does it also play the music while you're doing it?
Yeah, it plays Rachmaninoff's Third Piano Concerto.
Where is
No,
that?
it doesn't. I just added that music to YouTube. And it sounded cool. So Logan's going to talk about the test. Oh, I forgot to show
The actual
the actual thing. So here is the phone. So I have a hand down here, which is 3 pair of 3s.
So it won't print anything until it's found 5
Yes. Though I do have it printing which card it is for debugging purposes. You wiggle the 8. There we go. So you can see on the bottom it says 3 of a kind 3s right here. So, and then if we wanted to, we could change it so that now we have full house, 3s over 2s. And if we have gray background cards, it recognizes it much quicker. But full house, 3s over 2s. So now we go back to the presentation.
What does it do if you put out 5 aces? Does it say this doesn't look right?
Yes, it will throw an error with 5 aces. However, if you have 4 aces of like the same suit, it will just print 4 aces. Because that's there's nothing in it that's detecting if there's duplicates.
Right.
But it will recognize that there's 5 aces.
It assumes you're playing with a fair deck.
If you only have 5 aces, I'll probably shoot you.
So, for testing, we trained it on a different deck of cards that we didn't have. I ended up buying those just now. It's slightly different, so it's not working too well. But it is still working. We've got a bunch of training data on different poker hands to test the algorithm.
We also did some other types of testing and found some bugs. So originally we were storing the type of card as in a car, and I also encoded 10 as being 10, which was pretty dumb. But I was noticing that it wouldn't work if there was a 10 in it, and I thought maybe I forgot to take enough pictures of 10s for the augmented reality. The machine learning. But it turns out it was just it was a car, so it was actually picking up an underscore that was in the encoding, so that was kind of funny. And then originally we had a hard time getting it so multiple cards were recognized at the same time. You had to scan it one at a time with a bug in the XML, but we fixed that. So.
So the size of our GitHub repository of our GitHub directory is about 700 megabytes. We had 400 lines of code for the to tell which ends we have once that we recognize each single one of them. And the AR codes wasn't that big, but there was a lot of dependencies, and the dependency were much of the codes, but the actual code we wrote was 200 lines of code. And yes, that's what it.
So we estimated how big the project was going to be using story points. We had 81 total story points, and we completed 66 story points. So here's all the story points of everything that we have. The only thing we haven't finished is displaying in real time the which hand it is on the screen instead of on the terminal.
So the only required feature from the customer that we still have to implement is to overlay the text on the view. To do that, we need to use OpenGL. So I've been learning OpenGL for the past week or so because none of us has OpenGL background, and it turns out that it's actually pretty hard to draw text on OpenGL. You need to use bitmap, and like each text character is a single image. So we're working on it, and since we got really used using the different API, we could try to do what we originally planned, so build a custom model from ML kits to be able to recognize a more diverse variety of cards. And some stretches that we would like to implement and we're working on. So overlaying the probability of winning a rounds using the recognized end, and we're also working on building the AI that the user will be able to either play against or receive recommendation from.
So I guess in conclusion, what we did was bring together, we implemented augmented reality and machine learning, and hopefully we'll be able to, this will help Lexmark with their development of machine learning techniques for their augmented reality glasses. So I can try it on these. It works if they're partially overlapped. You have to at least have you at least have to have the corner. But on the cards we train on, it worked. It worked, but I don't know about these ones because it's not quite in the model correctly. Uncover it a little bit. Yeah. So with these cards, no, but with the other cards, it will. Because the numbers are just a little bit different, so it's having a hard time recognizing it.
Yeah. So whatever, what your training process looked like, and so how did you get machine learning to recognize cards, and also what kind of model did you use? Because I see that yours is detecting the rotation of the objects, and traditional just object recognition model detects rotation of objects.
Yeah, Wiki2 actually has a black box that if you, I think it's using some kind, I think it's a neural network.
But it's the recognition part is working on top of the augmented reality framework. So there is an image tracking API. So no matter the orientation of the image, the tracker is still tracking the image.
So you gave Wiki2 a bunch of images of cards, and then it did the rest for you?
Yeah, essentially,
Yes.
yes. But there is a framework you can can build your own, and that would actually be better because then it'll be less buggy with changes because we could add like noise and such things. So, but yeah, right now.
How big was your training set?
How big?
Yes.
So I think for the one that's working well, we have like only about like 150 images, and it takes them, and like the black box takes it and makes it the training set a lot bigger, if that makes sense.
It augments it by
Yeah,
adding rotations and stuff.
Yeah, by adding rotations and different things. But what we put in was, I think, 102.
So that's only about 2 examples of each kind of kite
Yes.
from one particular style of deck.
So from 2 particular styles we used.
Okay.
So there's usually, in cards, there's usually just the big, like the jumbo cards, and then the small ones. And so we did both of those.
I see. And they tend to use standard fonts.
Pretty standard.
Yes. Except this one is a slightly different font, but it still worked.
Right. And so this WikiTube, this is publicly available. Do you have to pay for it? How does WikiTube?
Actually, so ArcCore is from Google, so it's open source for the Android community, and WikiTube is proprietary. And if you go back to the first thing, so WikiTube is proprietary, and ArcCore is open source. And basically, Google only supports the last 2 releases of Android, and WikiTube pretty much supports almost everything, at least Lollipop. So what it does is that for the last 2 versions, it will call the ArcCore engine, which is open source, and for all the devices, it's calling its own engine.
Right, and what is it? I mean, what does it do? I know what Java is, it's a programming language. I know what SML is, it's a data representation.
Oh, yeah.
What is WikiTube?
WikiTube,
It's a Java package.
not really. It's basically like an augmented reality framework, and Google is doing some. Basically, like there is a I would say 3 main like producer in the market. So there is ArcCore from Google, which is open source. There is ArcKits from Apple. I don't know if it's open source, and WikiTube is a cross-platform library. So I know that it calls the ArcCore engine for the latest Android devices. So it will do exactly the same thing as Google implements for ArcCore.
You're not answering the question. You're saying that WikiTube has got ArcCore in it. You're not telling me what WikiTube is. What do I use it for? Can I use it to cook a steak? No, it's not a cooking program. What is it?
Well, it's a really broad augmented reality and image recognition framework. So there is a lot of things you can do with it. So it will be easy to give an exhaustive list. Image recognition is one thing. There is also object tracking and a lot of things.
So it's got tracking and it's got recognition.
Yes.
And the way it does recognition is you need to train it, and it says, well, I recognize that that's an ace of clubs because it's seen one before.
Yes.
So there's a training as with many of these.
And there is different ways to recognize there is different options. We are doing a straight 2D image recognition, but it has other options.
When you're doing the training, do you do it all on an Android device, or do you do it offline and then upload it
Yes.
yourself?
You train it.
It's basically cloud-based. You just upload the image.
So it trains on the cloud, then you download a WTC file, which you put in your Java program.
Okay, and what is WTC?
It's a three-letter acronym for something.
Fine, okay, so it's a format that it uses.
It's a format for machine learning files. It's like a .h5 file.
Okay, right.
So it seems like WikiTube is a bit like TensorFlow and an AR kit and OpenCV all packaged into one
Yes.
program.
And you could say the same for Arco.
Yeah.
But UKI is cross-platform.
Yeah, so there's one that works on only Android devices, one that works on only iOS devices, but WikiQ works on both.
And
But it's,
what did you program in Java? What part of this is Java?
so the augmented reality part is in Java. So like what you're seeing, the whole app is in Java, and then the code for once you have cards, figuring out which poker hand, that's in Java.
And do that we are we're not recognizing the entire end, we're recognizing individual cards, and from that we run a procedural mode, like a procedural code to know if I have this card, and that card, what end is it?
Right, that's pretty straightforward. It looks like you saw a bug in it. On one of your slides, it didn't mention.
Yeah, so there was a bug where
Sure.
royal flushes, it doesn't print the highest card, it just always prints ace, so I need to go back and fix it.
Okay, but that's just
Yeah.
simple decision code in Java.
Yeah.
When you say that the virtual reality is written in Java, you wrote a virtual reality
No,
application in
we
Java?
used one that they had already programmed and then changed it for what we had.
Okay.
So we didn't like write it from scratch. They had an example where it recognized a picture of it would recognize one picture of a server. Yeah. And then we changed it to recognize 5 cards.
What's in XML?
Basically, I don't know if you have done Android development before, but basically you declare all of the widgets in XML and you manage the events on those widgets using Java. That's how Android development is done most of the time.
So like the screen says, if you click this in the XML, then it calls the Java procedure.
So instead of declaring everything on Java, everything is already declared on XML. So Java is just a manager. But all of the resources, the UIs are declared in XML. You could also do everything in Java, but that's not how Android is most of the time.
Other questions? Oh, thank you very much. Now, for questions for Daniel, we have a little bit of time.
It's not really a question, but I just kind of thought it was interesting when I saw